Welcome to Christ Open Courseware. In today's video, we will be dealing with the stack data structure and its operations. So, what is a stack? In the earlier videos, I have told we have learned about arrays, we have learned about linked list, and now we are going to deal with stack. So, what is a stack? Let's do it with a figure. Suppose these are the elements. You have here elements 20, 55, 65, 70, and with positions 1, 2, 3, 4. So naturally 20 will be inserted first, 55 the next, 65 the next, and 70 the last. So what is happening here? Insertion happens through this portion, and this portion is known as top of the stack. So in the diagrammatic representation, stack can be represented as a stack of plates. What is the specialty of stack of plates? You have four plates here, one on the top of the another. Can you take a plate in between, or can you take the bottommost plate? No. If you want to take the bottommost plate, you have to take the plates above it, and that too one by one, right? So that what happens here is you are inserting and deleting at one point known as the top. So this is a diagrammatic representation of a stack in which you insert elements through the top and also delete elements from the top. So what happens when you delete elements from the top? First, when you do a deletion operation, what happens is first 70 goes out. So what remains is 65, then 55, and then 20, right? So now for the next deletion, what will be going? 65. So after this, what remains in the stack? 55 remains, and then 20 remains, right? So in again a deletion process, what happens is 55 goes and only 20 remains, and again you do a deletion process, what remains is nothing. So this is an empty stack, right? So what we have seen here is stack is a data structure in which operations on a stack, either insertion or deletion, can be done only through one point known as the top. So mainly in data structure, when you implement stack, you mainly implement it using already learned data structures, that is array and linked list. So in one of the videos I have told array and linked list are the basic concepts of data structure, and whatever data structure you use further, higher data structures, higher forms of data structures, you either implement it with the help of array or with the help of linked list. So the stack data structure we are seeing here now will be implemented using both array and using linked list. So let me tell the definition. What is the definition of stack? It is a data structure in which operations are done only at one end called the top. Okay, so in data structure stack, you do operations mainly push and pop. Push is called insertion, pop is called deletion, and it is done through the help of the one end, and that end is known as the top of the stack. Now let's see the representations of stack. First one, using array. How can be stack represented using array? we can take the same figure. We are familiar to array figure with like this. Take the same examples of the 4 elements. Right. So we have in array we have index, and that index will start from say 1, 2, 3, 4, 5, 6, and now we will insert elements. I have told the first element is 20, last element, second element is 55, third is 65, and the last one is 70. So according to stack, what happens is this portion is top. So even though we are implementing this using array, in array we know that we can do insertion and deletion in between any elements, but when you are using stack concept with the help of array, you should not do anything. Only insertion and deletion should be done at the top portion. So if you are going to do insertion, you have to start from the top. If you are doing deletion, you have to start from the top itself. So now that how that can be done, we will be doing going in the I'll be showing it in the following videos. So this is a representation of array using representation of stack using array. Now how can it be done using linked list? In linked list, when teaching linked list, I have told you that we have a header node, right? So similarly, you have a header node, and this header node here is also called stack head. Naturally, the data part is empty, it only contains the link part, and you have the linked list here. Naturally, we have only 4 elements, so I take only 4 nodes, and the last node naturally is empty. Let me draw the link. Now placing the elements in this, right, and that is the difference here. The first node, when you implementing using linked list, the first node is 20. So when I implement stack using linked list, when the first node is made, I insert the data 20 and make the link part as null. Then the second element is 55. I create a new node, put the data in the 55, put data 55 in the data part, and the link part contains the address of the first node. Then goes for the third element is 65, put it in the data part. The link part contains the address of the second node. Now put the data for fourth data in the fourth node, 70. The link part contains the address of the third node. So now what does stack head represent? Stack head represents our concept of top. So when we are implementing stack using linked list, what happens here is stack header does the job of top. Okay, stack header does the job of top. So naturally stack header will be pointing to the last element in the stack. So these are the two linked list representation and array representation of stack, and the following figures, this figure represents array and this figure represents linked list, and next we will be seeing the operations in stack using array and as well as linked list.